Hello YouTube and welcome to What the Math. In today's video we're going to be continuing chapter 15 and touching on a topic called cosine rule, or the rule or law of cosines. Now this is a slightly more difficult topic, but as soon as I explain it to you it's going to be super clear. Anywho, let's start with the triangle. And here's a little example. This is basically a triangle with three sides A, B, C and a green angle A. Now here's the question, and this is not a right triangle, this is just a regular triangle. It can be acute or obtuse, it doesn't really matter. But so here's the question: can we actually find one of these sides having just these three things and an angle? So is there any way for us to find these three sides? And the answer is yes, there is, and this is actually where law of cosines comes in. There's actually the answer for you right here, but I'm gonna show it to you step by step just so it actually makes sense. So let's just say we're going to find side A. We're going to try to figure out how to find side A if we have side B and side C and then an angle between them. So just like with the topic of areas of triangles, if you have these two sides and an angle between them, you can obviously find the area of this triangle, but you can also find the side opposite to this angle. And this is how you do it. So let's imagine we're going to draw a line here. And this line will create a right triangle. This is basically a right triangle. And we're gonna, we can always give it a name, or we can just basically assume that this little part right here now will become X. And this little part right here will become C minus X. So this is the side C, this is X, and this is C minus X. And this, well, it's the height, so let's just name it H for height. So now we have three new sides. The side C has been divided into two little parts, and we also have the height. Now, can we actually express these sides using Pythagoras theorem? Of course we can. So Pythagoras theorem, hopefully you remember it. It's basically a squared equals to b squared plus c squared, but in this case we don't actually have these particular sides as the right sides, or sorry, as a part of a right triangle. So we need to rewrite this a little bit, and we can obviously express this for this triangle here first. So let me just give you an idea which triangle I'm talking about. So this triangle right here. And let's start with this triangle. So we know that this is a leg, and this here is a hypotenuse. And so basically x squared plus h squared equals to b squared. So you can find b squared using these two sides. You can also find a in a similar way, because a is hypotenuse, this is a leg, and this is a leg. So here for side A, let's use a slightly darker color, a square, which is a hypotenuse, equals to h squared plus this part, and this part is actually going to be in brackets. This is where it gets a little bit trickier. Oops, I made a mistake. The bracket has to be here. So this is foiling. This right here we have to foil, and hopefully you remember how to foil this. Hopefully you remember the foiling rule, and the foiling rule that applies to this particular example is, so when we have two letters, let's just say c minus x, this will become c squared minus cx minus cx, so minus 2cx, and then plus x squared. So this is what this will become. So in other words, if I rewrite this now, it's going to become a squared equals to h squared plus c squared minus 2cx plus x squared. Now you may ask yourself, why am I doing all this? This is so complicated. This just makes no sense anymore. Well, here's why. If you look at this here, you look at this here, and then you look at these two, you'll realize that you can actually replace these two, just basically cross them out, and replace them with b squared. So a squared equals to c squared plus b squared, which is this part, minus 2cx. Okay, so we're getting somewhere here. It's a little bit easier now. But what is x? We don't really know what x is, right? We know what c is. C is a side, b is a side, a is a side. So what is x? How do we actually change this? Well, this is where trigonometry comes in, specifically the cosines. if you look at this, closer, cosine of A in this case, I'm going to use this color here, cosine of A, which is cosine of this angle right here, cosine of A equals to what? The adjacent side, x, divided by the hypotenuse, d, right? So this divided by this. And if you were to multiply both sides by b, basically if you were to rearrange this for x, you can say that cosine A multiplied by b equals to x, right? Right, so replace them. Well, let's replace them to get the following. A squared equals to c squared plus b squared minus 2b c cosine A. And if you look to this table that I had all this time, it's exactly what it says right here. In other words, to find a side of a triangle when you don't really know if it's the right triangle or not a right triangle, if you have two other sides and an angle between them, what you have to do is you have to square one of the sides. So in this case, we're squaring c, so c squared plus b squared, and then we're subtracting minus 2 times b times c times the cosine of angle between them. And this is what this right here says. Now you don't really have to memorize this because this will be on your formula sheet in math studies, but you just have to understand why we have this complex thing, and most importantly, what is it for? So this is for examples like when you really have just a triangle. You have a triangle and you have a side here and you have another side, and let's just say you have an angle here. It says 52 degrees. And one of your questions may ask, well, find the area or find the side C. And to find this side C, you would have to use the law of cosines. So basically, this is how this works. So let's actually try an example before, so it kind of makes a little bit more sense to you. And we're going to try two common examples here. One is example 16 from page, I believe it's page 469 in your book. And here we have two sides, we have an angle, and it says find the length BC. So find this length, and right away you can obviously solve it by doing this and then doing this and then trying to figure out what the rest of the things are, or you can right away just look at this formula here and realize that BC squared equals to AB squared, which is the other side, plus AC squared minus 2, I'll just call them, I guess I'll call them by names, AB times AC times cosine of 72 degrees. And this is squared, of course, so of course we have to take a square root of all this, but before we do that, let's actually add this all up and see what we get. And if you add this all up and you subtract this part, you will get an answer that's approximately 8.39 centimeters, which is the measure of value CB. So this is a relatively easy question. Now, sometimes, however, you'll actually have a slightly different question, which will ask you to find the angle if all three sides are given to you. So imagine a triangle where three sides are given and you have to find an angle. And here's the example for this type of problem. So this is example 17, right on the next page. And here we have a triangle ABC. So let's just draw it really quickly. Triangle ABC. Where AB is 7, BC is 5, and CA is 8. They want you to find the angle BCA. So this angle right here is unknown. Now, how do we find this? Well, this is, of course, where we also have to use the law of cosines, but this time we have to rearrange the equation. Now, specifically, we're going to be rearranging it for the side AB. So here, according to this law of cosine, AB squared equals to this side squared, BC squared, plus AC squared, the other side, minus 2 of these sides multiplied together, and multiplied by cosine of the unknown angle. Let's just call it x, angle x, cosine of x. So let's rearrange this equation so that we can actually solve for x. put all of these on the other side first. So basically subtract, or let me just show you what I mean. Subtract this and subtract this from both sides. What we'll get is this: AB squared minus BC squared minus AC squared equals to minus 2BC times AC times cosine x. Next step is to divide both sides by minus 2BC times AC. So basically we're not subtracting, we're dividing everything by this little piece right here, which is, you can assume this is a number. So let's just basically divide everything by this, and what we'll get is, so there is a negative sign here, so everything here will change signs. So this will become minus AB squared plus BC squared plus AC squared divided by BC multiplied by AC, and all of this equals to cosine of x. And the last step here, before we basically use the calculator, is to realize that here we're actually looking for an angle. And when we look for an angle, we have to use the inverse of a cosine, sine, or tangent. So this is actually the inverse cosine of x. So this is what you'll be entering on your calculators. Now, for now, all you have to do is basically change this into numbers. So let's do that on the bottom right here. So what is minus AB squared? So AB is 7, so this will be minus 49 plus BC squared plus 25 and then plus 64, which is AC squared, divided by BC times AC. So BC times AC is 8 times 5, which is 40. And I just realized I made a mistake. I totally forgot about the 2. This has to be divided by 2 as well. So the 2 stays with these, which means that this on the bottom will be actually 80, not 40, it's 80. And all of this will be equal to the inverse cosine of x. So let's calculate what this number is. I'm going to write on the left here. So the top part here will be 40 and the bottom part will be 80. So this is essentially 1 over 2. Let's go to the calculator. And inside the calculator, we're going to enter the inverse cosine of 1 over 2, or you can just say 0.5, which is the same thing. 0.5, enter, and if you get this answer, this is because you did what I did. You forgot to change this to degrees again. Change this to degrees, do this again, and the answer is right here. It's 60. So this x is 60 degrees. And that is the answer for this question. So this might seem like a slightly more challenging problem because of all the rearrangement and stuff. But the thing is, it's actually simple as long as you remember how to rearrange the formulas, which is a topic we covered maybe 6 or 7 months ago. But as long as you remember how to rearrange everything and solve for x, you should be absolutely fine. But do expect to see questions like this where you have 3 sides, it's not a right triangle, and you have to find the angle. So you can't really use cosine, sine, and tangent right away, but you do have to use law of cosines first. So anywho, so this is how you solve these problems. Hopefully this was clear, and good luck to you. See you soon. In the next video, we're going to be dealing with the law of sines, or the sine rule. Anywho, good luck to you. Bye-bye.